Let us go to the topic called controllability of active, and that is this controllability of the active steering system is taken from the standards to the type text. Okay. Whenever you go for any new development, the question arises here is during the earlier risk, what can go wrong? Okay, what are the risk analysis for a particular system? And how you can have the control over the system in case of the such. Here you need to ask the question: how much deviation can be controlled by the driver? Okay, and you should also ask the deviation between the desired input and then output, depending upon the different condition of the road condition. You also need to have the feedback control algorithm to ensure that you do not have the proper means you do not have the hazard during the installation with respect to various aspects. So here, whenever you look at the failure, you have different type of failure, as I was telling yesterday. So the very important scope that you have uh, during the analysis or during the system development of the steering system is that you need to understand the different nature of the actuator or the functionality for to ensuring the comfort for your steering system, and you also have different controllers or different actions, like you have feed forward action, stability actions, you have forward actions, and you should also understand what is the role of the driver during the feedback uh, of the forward feedback or the stability feedback, and we also need to look for some of the guidance considering the role of the driver. So here you have the EUC, which is nothing but equipment under control, and you need to understand the residual risk and what is the actual risk that you have for your electronics components, and accordingly you need to take the control over the situation as well. And here, yesterday we have seen the variables, two variables. One is a variable steering ratio, and also we have seen ORC, which is nothing but rate control. When I say the variable steering ratio, it will vary the ratio between the hand steering wheel and the road wheel, and also the vehicle during stabilization. For example, when you take the ORC, uh, it will help for the function of using the actuator. It will also help during the as I was telling you, you have different functions like forward functions, feed forward functions, feedback. You have the stabilization function. When I say the function here, in the last case study we have taken example of a malfunction of a battery. There is nothing but overcharging. Okay, so here accordingly you can also take a function like stabilization command can be one of the function, or the actuator controller can be one of the function for your steering system. Okay, and accordingly you can design the hazardous operability system requirement for your particular steering system. So as a first step, what we have to do is we need to look at the difference between the forward and also the feedback system into the vehicle level system or the system level. When I say system level, you have the two parameters. One parameter is related to variable steering ratio, another one is respect to the ER rate control. Okay? And this needs to be considered with respect to the, and here when you go for a area design stage, ASAP stands for asset operability. When you go for a yearly design stage, considering the ASAP for a VRC or a VSR, you need to consider some of the things. Okay, uh, so here what are the conditions if no, if more or if less or if good, and also command with respect to VSR and also YRC. So this table, in the case of no case, see here is no case, okay, response. Here there seems to be some of the 10 implication onto the VSR function, but not for YRC. Okay, there can be here you have the implication onto the VSR, but not for YRC. While in the case of VSR functions, there can be some commands which includes the driving conditions and also the amplitude, etc. Okay, so here this table will concentrate on the systems, which will help you to minimize the feedback by the driver, and this also helps you to carry out the detailed thing for with respect to the driver reaction as well. Okay, this is the initial level of analysis which is required to understand the situation and also to understand the command and also to understand the feedback and also to understand the behavior with respect to the different scenario. So here the scenario is what will happen if zero angle is added, what will happen if more amplitude are been applied than the expected value, what will happen if less amplitude is been applied but if it is less than the exact value, what will happen if the steering is operating in the opposite direction, what will happen if the reaction time is going to be less or late. Okay, so you need to steer your vehicle, right? So when you steer the vehicle different means maybe with delay, what will be the impact? So here there are two impacts considering the variable steering ratio and also the yaw rate control. So when you say yaw rate control, you also understanding the command that you are going to stabilize it, and you see what will happen if no or zero angle being added with respect to your command. If this is the command or if this is the requirement, then you see the variable steering ratio command is going to fall back to the mechanical steering, and these steps is depending upon the VSR layout, and it also depends on the driving condition. When you look at the stabilization command, it's also same as VSR when no command is been applied. Otherwise, as I was telling, there is no impact onto the YRC if there is no angle has been added, but there is some issues coming onto the VSR, and it also depends beginning on the driving condition as well. When you have the more amplitude than the current, what happens is your steering is too direct. It depends again on the driving and the situation amplitude. So here the driver aspect comes in the ASAP one or during the initial stage. That's why it's very important to arrive at the detailed explanation with respect to the second level, considering the driver reaction. It's very much important that you need to analyze at the first level, considering the command and also the requirements. This is where the uniqueness also comes. You're asking the DFME, FMEA. Here, you consider all the functions and you look at the malfunctions also, what can go wrong. And with that malfunctions, again, you derive at some of the requirements that should be a part of your safety design as well, or your item definition. One for you to consider ISO 26262. And here you are not only considering ISO 26262, even you are also going for the external requirement called GOC, even the ISO 214448 for SOTIF, what we have seen, even that also needs to be considered. But this electrical electronics, when you go for electrical electronics, you go with an EDF and EA in a manner where you have severity, probability called E, and controllability called C. Okay, and looking at the other aspects, what will happen if you have less amplitude than the correct? The steering is going in the same direction, so steering becomes indirect, and it also depends on the driving situation and also amplitude. And here in this case, the YRC is not being carried out correctly, and the vehicle is not going to get submerged. And this also depends on the amplitude. What will happen if you have the reverse direction? when the steering wheel reverses, what happens? Your vehicle steers in the wrong direction, right? It means what the command here is, vehicle is not going to get stabilized. What will happen if you have the left steering time, or when you are steering your vehicle left? Okay, it feels also awkward, and also it depends on the delay. Okay, the more you delay, you also have again here also you do not have the vehicle getting stabilized because of these conditions. So you will not have you will not have the vehicle stabilization in the case of left steering, or in the case of reverse steering, or in the case of uh, less less steering when you apply. Okay, even when you apply less steering, what happens? Depending upon amplitude, still the vehicle is not going to get stabilized. And if you oversteer also, again it is not getting stabilized. And again it all depends. Okay, how much input you are giving concerning the various aspects. Accordingly, the vehicle can be stabilized or de-stabilized, and accordingly, the variable steering ratio command and also the YRC command can get varied. Okay, so considering the first sub with respect to the command, what I was telling related to YRC and the SR. So here we are also considering the driver aspects. First will be with respect to the system. Then we are also considering with respect to the system aspect. What will how the driver will react? What will happen if driver reacts? If there is no reaction from the driver, if there is fast reaction from the driver, if there is if depending upon the situation, if it is no load acting onto the steering system, or if the load is acting in a reverse direction, if there is less load acting onto the steering system, more load oversteering is happening into the steering system. Okay, the same thing is also applying here. So here, depending upon the system thing, say for example, if the command is reverse, so what the driver will do is that the driver will turn the hand, the wheel in opposite direction, as I say. When the command is trying in the reverse direction, then to avoid the reverse direction or opposite direction, what the driver will do is that he try to put it in opposite to opposite. So he may try to stabilize the vehicle by going for a correct steering ratio, and also again this also depends on the driving situation and under what condition is driving, and also the amplitude of the vehicle or the situation. Here, it is possible for him to correct it. He can also reverse it when there is again the command coming in the reverse direction. And you see here, when the steering is more, when the command is applying uh, more speed onto the wheel. So how the driver can react? The driver will react such a way. He will also make the steering even more direct. He will try to make it more direct one. And again, it's also depending upon other aspects related to the driving situation and amplitude. But even though the vehicle is not stabilized initially, but the driver tried to go for a stabilization, but still the stabilization is not possible if you do not have the proper driving situation or amplitude. But still, the driver reacts such a way to ensure that he is trying to stabilize the vehicle. Say for example, if it is too much fast, and if there is no vehicle reaction, and if the driver is reacting such a way, still it may not be possible for him to stabilize the vehicle. But there are some conditions where he can try to destabilize, and the very important thing is that it is very much important to look for the controller, and also the command should be such a way you should stabilize the vehicle and to ensure that the steering is being achieved, because this may lead to some of the hazardous issues like um, say when the vehicle is running at 100 km per hour, and you have the steering lock, and or when you have oversteering, what happens is the driver becomes very difficult for the driver to control. When it becomes very difficult for a driver to control, it becomes C3. When you have C3 level, and when the severity is going to be high because the vehicle is running at 100 km per hour, severity is going to be high in case of any accident. So S3 will be coming into the probability of the failure, yes, the probability is going to be extremely high because um, you are going to have oversteering or steering wheel gets locked. Both are an issue when in case of vehicle running at a high speed. Okay, so and again the probability is going to be E4. So E4 into S3 into C3 will be the combination which will result in category called D. So all this needs to be considered and accordingly you need to go for a design. Okay, so this is the checklist that you need to look when you have. So we have seen two asserters operability. One is 1 and 2. So one is related to the command VSR and YSR to stabilize the vehicle, and based on that, also have the asserters operability two parameters considering how the driver should react for your variable steering ratio or the VRC. So this checklist needs to be taken care. Um, what should be the one with respect to the SRS layout or the VSR or OSR layout, that all this needs to be considered, and how to map the terms considering more or less in the case of SRS operative one table onto the regulation error, and how to map the late onto the regulation error, timing issues. All this needs to be taken care as a part of your system design as well. And do we have to react differently in different situation? Here, do we here indicate the driver how to how the driver should react according to the driving situation, and also based on some of the worst case assumptions. In the case of status operability truth table, we also need to ensure that whether we need to consider the message encouraging the driver to release the hand wheel. Sometimes what happens, the driver also needs to release the hand wheel. Okay, sometimes it may be very tight or it will be low. Means the amplitude will be low. Accordingly, you have to take the actions accordingly. Or he can also reverse the thing, reverse the hand wheel when the command is coming in the reverse direction. So the main objective is to stabilize the vehicle, and accordingly the command can be taken as an input for the driver to control. So you have the rating. So you need to ensure that you have the proper control over the vehicle. If the vehicle is not able to control, you have it as a rating is 10. And here you have the rating between some 7 to 9. You have the dangerous aspects, and 4 is annoyance, and 1 to 3 is controllable, where you have noticed 1, and rating 0 is not perceived at all. But always aim for rating 1 to 3, where it can be noticed and you can take the corrective action accordingly. Okay, so when you say rating 0, it is something like um, you're going for a best case, but that will not happen sometimes. When you go for a design, especially, you need to have some rating, and accordingly, you need to take that as a input for you to take the proper even if you consider the architecture, considering the rating as well, because when you say rating, you are having the proper control over the failure. When you have proper control over the failure, you can ensure that all the architecture into the system um, are meeting all the functions without having any failure. Okay.